Welcome to this explainer. Today we're diving into Lesson 6.3, Earth's Restless Foundations, the Science of Continental Drift. We're going to completely break down the fundamental structure of our planet, and honestly, the fascinating mechanics that keep it in constant motion.
You know, it's so easy to assume the Earth beneath us is just this permanent, static fixture. I mean, when we build houses or lay down roads, we kind of expect the ground to stay exactly where we left it, right? But science tells us a very, very different story. The reality is that the ground you are standing on right this second is actually on a journey. It's moving. And to understand how and why that's even possible, we really have to look back at the grand scale of our planet's history.
4.5 billion. Scientists have figured out that our planet is approximately 4.5 billion years old. For centuries, we basically assumed the Earth was entirely static and unchanging. But over those billions of years, our world has been undergoing continuous, incredibly dramatic transformations. And to figure out how this level of change even happens, we can't just look at the surface. So, inside our planet, let's peel back the layers. We need to physically drill down past the surface to see what exactly makes up the Earth's interior. We're going to treat our planet almost like an onion here, because what is happening deep, deep underground is quite literally the engine that drives everything we see on the map today. Right at the very center is the core. It's made mostly of nickel and iron, and it's split into a solid inner core and a molten outer core. Surrounding that is a massive, thick layer we call the mantle. And finally, wrapped all around the outside, kind of like the thin skin of an apple, is the solid rock crust. That incredibly thin outer shell is where all of human history takes place.
Now, this mantle is absolutely crucial. It consists of magma, which is intensely hot molten rock that flows almost like a thick, heavy liquid just beneath our solid crust. Imagine sitting on a raft in a gently moving river. In a geological sense, the solid crust we all stand on is essentially resting right on top of this flowing liquid rock.
And if we zoom in on the actual composition of that solid crust we live on, the proportions might genuinely surprise you. The most abundant element up here is actually oxygen, a non-metal. After that, we've got silicon, and then your metals like aluminum and iron, along with a mix of other elements like calcium. So this solid rocky shell feels incredibly durable to us. But its relationship with that flowing mantle beneath it, that is where things get truly exciting.
Knowing that there is flowing liquid rock just beneath our seemingly solid surface brings us to the continental drift mystery. Back in 1912, a German scientist named Alfred Wegener looked at the world and proposed an idea that completely shocked the scientific community of his day. He suggested that, over millions of years, the land masses we know actually broke up and drifted apart. He called this, naturally, continental drift.
And Wegener didn't just throw a wild guess out there, he brought the receipts. He boldly suggested the land was once one giant supercontinent. First off, he pointed out that the shapes of the continents fit together remarkably well. I mean, just think about how the coastlines of South America and Africa look like puzzle pieces. Second, he showed that the exact types of rock on different continents matched perfectly where they supposedly fit together. And third, identical fossils of plants and animals were found on completely different continents that are now separated by vast, impassable oceans. There's no way that's just a coincidence, right?
Mapping this all out chronologically paints an absolutely incredible picture. Let's rewind to around 225 million years ago. All land was merged into a single supercontinent known as Pangaea. By 150 million years ago, Pangaea had split into two massive landmasses, Laurasia up in the north and Gondwana down in the south. Fast forward to 100 million years ago, and the continents are drifting further apart, starting to look a bit more recognizable to us. Finally, millions of years later, we arrive at the modern continental layout of the Earth as we know it today.
So, with all that matching rock and fossil evidence, you'd think his peers applauded him, wouldn't you? Well, they didn't. Despite his compelling evidence, Wegener's theory was widely rejected at the time. Why? Because he simply couldn't explain exactly how continental drift happened. I mean, what forces could possibly be strong enough to push entire continents across the globe? Because he couldn't explain those physical mechanics, people just didn't buy into his ideas.
Which brings us to moving tectonic plates, the real engine of drift. It wasn't until much later that scientists discovered the missing piece of this massive puzzle. The big revelation was that the Earth's crust isn't one solid, continuous shell like an eggshell. It is actually broken up into massive pieces, and these pieces are the true engines of continental drift.
It turns out the crust has fractured into these distinct, large slabs called tectonic plates. Some form the continents we live on, those are continental plates, while others sit deep under the oceans, known as oceanic plates. And these massive, heavy plates, they sit directly on top of that hot liquid magma mantle we talked about earlier.
If you want to visualize how this actually works, you can easily model it. Imagine floating pieces of polystyrene in a heat-proof dish of water. When you gently heat the water from below, which basically mimics the Earth's extremely hot core heating up the mantle, the water starts moving in currents, and as it flows, those polystyrene plates just drift right along the surface, perfectly mirroring how magma currents carry those massive tectonic plates.
Now this grand, planetary movement, it is happening right now, but it is constant and agonizingly slow. Because of the incredible friction and just the sheer mass of the rock involved, these tectonic plates shift incredibly slowly on the liquid rock beneath them. We're talking a movement of only about 4 centimeters every single year.
To put that incredible geological scale into an everyday perspective, think about this. The solid ground beneath your feet, which is literally carrying entire continents and oceans, is currently moving at the exact same speed that your fingernails are growing. It's a tiny, completely imperceptible distance day by day, but stretch that out over hundreds of millions of years, it completely reshapes the face of our entire planet. Knowing that our seemingly solid Earth is actually this dynamic, constantly shifting puzzle leaves us with an amazing realization. The map of the world we use today, it's just a temporary snapshot. If tectonic plates continue moving at the speed of your growing fingernails, it really makes you wonder, where are these incredible forces going to carry our continents 100 million years into the future? What will the new supercontinents even look like? It is a fantastic reminder that our planet is alive, restless, and endlessly fascinating. Thank you so much for joining me on this explainer, and remember to keep questioning the ground beneath your feet.